Hi, everyone. Thanks for joining us. I'm just going to give it a little 30 seconds here, wait for more people to join, then I'll give a little intro and we'll get the webinar started. All right. Now that we're a minute in, I'll just go ahead and get started with some housekeeping. Thank you everyone again for joining today. This webinar is being recorded and the slides will be distributed with a email sometime at the end of the week. All webinar resources are on our website under the archive file. Any questions and comments during the webinar today, please drop it in the chat, the Q&A, or hold it to the end and you can raise your hand and I can take people off of mute if you would like to ask your question live instead. But with that, I will hand it over to our presenter today and we'll get started.
Thank you, Kate, and good afternoon, all of you. Thank you all for joining in, and thank you for your interest in this topic. I'm Saurabh Shekhadar, Senior Energy Engineer at ICF. Today, I'll be presenting our ET study findings of the project named Pool Heating Analysis. Next. So here's the working team for this project at ICF. I led this ET study under the guidance of Stephen Long, who is Director of Engineering for West. And I collaborated with Evan Davis, primarily for tool development. And Eva is overall Get Program Manager, who helped in all the milestones of the project. So here is the agenda for today's presentation. First, we'll go over the background of this topic and research objectives. Then we'll briefly discuss the findings from literature review and subject matter experts. Then it would be followed by our results related to parametric analysis as well as updates from the tool development effort. Lastly, we'll conclude the presentation with key results and recommendation. So let's start with the introduction and background of this topic. This slide outlines the pool heater market characterization in the US. As you can see on the screen, total number of pools in the US are about 10.7 million, with about 97% of them being residential. And as far as number of pools per state are concerned, California has the second highest number of pools per state after Florida. And majority of the pools located in California are outdoors, and they are situated in locations where the weather is primarily characterized as mild winters and hot summers, which make them ideal for outdoor pool applications with extended swimming seasons. The typical swim season, it varies for different climate zone, even within California, but the typical season is between May through September, and pool heaters play an important role by uh, extending this swim season as well as extending the life of pool and resources. I would like to highlight that the total estimated cost saving potential of two emerging technologies. First of all, gas absorption heat pump. The estimated cost saving potential is about 78 million US dollars and about 70 million US dollars for hybrid pool heating, and this is considering 60% adoption in the state and saving estimates coming from the later part of the study. Next. So this slide summarizes the key research objectives of our study. One of the important objectives was to synthesize the insights from literature as well as subject matter expert interviews, since pool heating or pool heating equipment is a niche topic. Another important objective was to update an existing Excel-based tool developed by ICF to model hourly energy usage, cost, and emissions for alternative pool heating technologies and facilitate that comparison of different technologies with a focus on California climate zones. Also, the objective was to assess energy cost and GHG emission saving potential, and as I said, with a focus on California climate zones. So we go to the next slide. So this is a brief background on pool heating and pool heat losses. There are several heat loss components from pool that causes the temperature to drop to uncomfortable levels. Previous research indicates that major contributor is evaporation heat loss. It is approximately 60% of the total heat loss for outdoor pools. And there are several factors that affect evaporation heat loss, including air temperature, wind speed, humidity of air, and pool water temperature. Other heat loss contributors are convective heat loss, solar radiation, and we learned from literature review that conductive heat loss to surrounding materials is small and can be neglected, as it is uh, significantly small compared to other pool heat losses. Also, it's important to note that evaporation heat loss is higher for occupied pools due to increased air to water contact area and pool cover. When placed on the surface of the pool, it it could prevent this heat loss from the surface, and energy savings up to 30% are possible. As far as typical size of pool heater is concerned, that is between 75 to 250 uh, kBTU per hour. And again, it is a function of the size of pool and whether the application is indoor or outdoor. As far as the set point is concerned, it varies between 78 to 82 degrees Fahrenheit, where 78 Fahrenheit is common for competitive swimming and 80 for multifamily outdoor pools, as well as like 82 is more common for pools occupied by younger children and elderly people. Next. This slide summarizes that gas pool heaters are the baseline technology, and they are ideal for heating pool that large volume of water quickly. And as I said before, there are certain factors that affect sizing of pool heaters, which include pool water set point, average temperature of coldest month in the season, and pool surface area. There is a reference formula listed on the DOE website, which is typically used to size the pool heater, and it's a function of temperature, set point, surface area, and the average temperature of the coldest month in the swim season. So this table, it summarizes the comparison of heating cost for typical swim season for LA as well as SF, and it is also shown for different pool water temperature set points. You can also see the typical swim season length is also different, so that is the reason why you're seeing a slightly higher cost for LA compared to San Francisco climate zone. And these numbers are pulled from DOE website as well. And I have added some references as far as the rates are concerned. Next. So after talking about the baseline gas-fired heating technology, let's talk about gas absorption heat pumps. There are two major manufacturers which we studied for the part of this project. One manufacturer has capacity up to 80 kBTU per hour, and the unit is modulating, whereas the other manufacturer has the unit has capacity up to 123 kBTU, and it is typically on and off type of equipment. The technology it focuses on extracting heat from outdoor air or ambient air, and the mixture of ammonia, water, and it takes that heat and transfers it to pool water via external heat exchanger. So the pool water is directly not added to the loop. It is heated via that external heat exchanger loop. So any properties or efficiency of that heat exchanger also plays a crucial role as far as overall system design and efficiencies are considered. But main point of the slide, GHAPs have this ability to maintain high efficiencies at lower temperatures compared to domestic hot water application, and they can produce water temperatures up to the required range, and they could be ideal for this application, and especially ideal for being the base load, and existing gas-fired pool heater can handle peak loads as necessary. Also, several units can be coupled or added to increase the overall heat output of the system. So this summarizes the lessons learned from the best practices guide released by Fortis PC. Next. So this slide denotes a high-level comparison of different types of pool heating technologies, including traditional gas-fired heating, GHAPs, electric heat pump, and solar pool heater. The comparison on different metrics is with respect to the baseline traditional gas-fired pool heaters. The primary advantage of using a heat pump pool heater, as indicated in the table, is higher COPs and low or almost zero GHG emissions. However, our previous research indicates that it has lower capacity output per unit, and the operating cost of the system would be significantly higher in California compared to other states. Solar thermal pool heating, it utilizes solar radiation for heating water, and essentially it can be paired with any technology discussed before. Hybrid pool heater, the technology is not new, to be honest, but the uniqueness is the combination of heat pump and gas pool heater in one housing, and it has integrated titanium heat exchanger. So there's no need of external heat exchanger like we discussed for gas absorption heat pumps. Also, the switching of gas and electric can be done based on outdoor air temperature, and both parts of the system can run at the same time on dual mode as well. So this is about high-level comparison of different types of technologies that we considered during the literature review or SME interviews phase, and then we added these technologies into our existing Excel-based tool. Next. Let's move on to the exciting part of the study, which is analytical tool development and updates. Next. So this is a snapshot of our spreadsheet-based tool. We updated our existing tool to add different types of technologies discussed before, and you can see the input tab, which collects information about pool type, whether it is indoor, outdoor, and even pool location, as well as sorry, when I said pool type, I meant residential, multifamily, or club, and yeah, pool location, outdoor as well as indoor, climate zone in California, assumptions related to pool cover, more information about pool set point, existing as well as proposed equipment. So this is essentially gathering information about the current site. It also includes operating hours of the pool as well. And as I said before, different swim season assumptions for each climate zone. It is automatically popped up based on the case study. And there are certain ASHRAE reference values which are used in heat transfer equations, which include solar shading factor, wind shielding factor, and activity factor. So those are also popped up based on the pool type selected. The DOE reference formula is used for sizing of pool heater, which is based on the average temperature of coldest month, set point, and surface area. We assumed same factors and same cases as far as the pool cover is concerned for both baseline as well as proposed, so that the energy saving potential of alternative technologies, they don't coincide or interfere with the cover related assumption. But we also took that as an opportunity to understand the impact of pool cover on overall energy savings. There's an option to add solar collector area as well. If it is 0, it assumes that the solar thermal heating is absent, but there's certain recommendation based on pool surface area as well. So if it is non-zero, solar thermal can be paired up with any technology discussed above. For GHAP related assumption, we assumed for that GHAP takes on the base load, and existing gas-fired heater, it kicks in for peak heating loads. So the idea is not to take the existing gas-fired heater out of the equation. Right now, it is set up for one manufacturer based on the manufacturer provided performance data, but this tool has adaptability or ability to set it up for other manufacturer as well. Our previous GET studies demonstrated that it takes about 20 minutes to achieve steady state COP for given operating hours. So we assume that for the first hour when GHAP kicks in, the heating outputs and flow rates are about 2/3 in that first hour. As far as GHAP is concerned, another important assumption is related to heat exchanger effectiveness, which is significant in determining the energy saving potential. And for hybrid pool heater, we assumed two modes. The first one being minimum cost mode, where the gas component kicks in first and then heat pump. And for efficiency mode, the heat pump component kicks in first and then the gas side. And similar certain assumptions for COPs were made for electric heat pump. But this is an important slide summarizing the assumptions that we made and the interface of our spreadsheet-based tool. Next. So this slide summarizes the parametric analysis that we conducted as a part of this project, as well as certain features of the calculations tab. So this is one of the representative plots, and you can see the table summarizing the list of parameters that we focused on in this milestone, such as climate zone, pool types, heater types, and effectiveness of GHAP heat exchanger. The comparative analysis was primarily done considering the mentioned output variables such as baseline and measure case therms usage, kWh usage, cost, GHG emissions, and percentage load from GHAP, just to understand for how many hours the equipment is on, and if the equipment is able to meet the desired load. Overall, the objective of doing this exercise was to determine the most significant parameter which affects energy savings and create impactful data visualizations in Power BI. Next. So first of all, let's talk about the impact of pool cover on total heat losses in an outdoor pool. The first plot demonstrates that the evaporation heat loss is the main contributor, as indicated in the literature review, and it also shows that there is significant reduction in evaporation heat loss when the pool cover is on, and this is in comparison with other types of heat losses. The second plot is very interesting. We can infer that minimal or almost no heating energy is required to heat outdoor pool when the pool cover is on during unoccupied times. And this is for one of the randomly picked climate zones, climate zone 9, which is closer to LA area. Next. So this slide shows the comparison of energy as well as GHG emission savings for outdoor pools in multifamily sector. Our analysis for the climate zones in California and focusing on this multifamily sector demonstrates that GHAP has the highest energy saving potential up to 28%, and followed by hybrid heat pump when run on minimum cost mode, which is closer to 25%. And as expected, heat pump as well as hybrid heat pump when run on efficiency mode they both have the highest GHG emission saving potential compared to other two. Next. This is the comparison based on the building type, highlighting higher savings in residential pools for the assumptions that we made compared to larger size outdoor pools. Next. The energy cost savings were normalized with respect to pool surface area, and this plot shows the comparison of normalized terms as well as cost savings for different climate zones in California. And for outdoor pools in multifamily sector, we noted that the highest normalized cost savings occur in climate zone 7, which is San Diego, and the primary reason could be higher utility rates compared to other climate zones in the state. And we also noted that similar trend was seen for hotel sector as well. Next. As we anticipated, this was a critical design parameter, the effectiveness of the heat exchanger and gas absorption heat pump loop, and we tried to analyze the impact of that effectiveness on the percentage cost savings as well as normalized cost savings. So as expected, the percentage cost savings increase with increase in the effectiveness of heat exchanger, and effectiveness should be above or at least 80% for positive energy savings. Next. This slide focuses on solar thermal paired with other technologies for outdoor pools, both in multifamily as well as hotel building types. And in this parametric run view and following results, we saw that the same pattern was observed for both. Hybrid pool heater, when run on minimum cost mode, has the highest normalized cost savings when paired with solar. The heat pump has the highest GHG emission savings percentage when paired with solar. Next. So we did this similar analysis or equivalent analysis for indoor pools with certain characteristics as well. And we assume that the pools are operating year-round compared to a typical season-wise operating, and different ASHRAE defaults were populated as far as the pool type are concerned. And again, we noted that GHAP has the highest energy saving potential for primarily for larger pool types where the equipment stays on for majority of the hours due to predictable steady loads for larger sized indoor pools. And as we saw for outdoor pool cases, the heat pump and hybrid pool heater, when run on efficiency mode, has higher percentage of emission saving potential, similar to what we saw for outdoor pools. Next. So let's talk about our key conclusions and recommendations from this CAT study. So key takeaways from this analytical or tool development study. The first one being the importance or impact of having pool cover on heating energy required. For one of the representative climate zones, we saw that almost nothing or minimal heating energy is required when pool cover is placed on residential outdoor pool during unoccupied times, which highlights the importance of pool cover measure. GHAPs demonstrate the highest cost saving potential, followed by hybrid pool heater for multifamily sector. And for indoor as well as outdoor pools, we noted that heat pump pool heater and hybrid pool heater, when run on efficiency mode, demonstrates the highest GHG saving potential. The effectiveness of heat exchanger in GHAP loop is a critical design parameter, and we discussed its impact on energy savings a couple of times. We also presented this study at 2-3 conferences over the period of last year as well as early this year. We also presented a poster about this at BECC conference in Sacramento. And from those presentations as well as interest, I try to summarize some of the recommendations for future studies. One of them includes doing tool updates for adding above ground residential spa hot tubs, and doing brief analysis on pool plus spa configurations in multifamily as well as hotel sector. And I talked about GHAP manufacturer. Right now it is set up for one manufacturer, but the tool has ability to add on another manufacturer as well. Also, we can update this tool for other climate zones and states as well. So that's about the recommendations for future studies. And next. Yeah, feel free to reach out to me if you have questions, if you're not able to answer that during the call, and if you want to have a follow-up conversation regarding this project. And also feel free to reach out to Ava Donald, who is overall CAT program manager. Thank you so much. And looking forward to your questions. Any questions for me?
I think I got a question. Saw someone's hand. Maybe
Ryan Rodriguez. but
Ryan, I
he's,
can take you off of mute if you'd like. I'll allow the mic.
Thank you. Yes, that might have been answered earlier. I saw that there was mention about pairing solar with these opportunities. Just was wondering if there's opportunity to use the tool to run an analysis for solar with the heat pump option.
Yes, the tool has the ability to do that analysis in combination with the heat pump, like essentially solar thermal plus heat pump. Yes.
Thank you.
any further questions for Saurabh? All right, there are no further questions. Saurabh, thank you for your presentation. And thank you all for attending.
Thank you, Stephen. Thank you all.